This is the Amp Hour Podcast, released October 27th, 2019. Episode 464. KonnectorPanik.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, man. We're making antennas around here. I've been making antennas lately.
I saw that. Yeah. Milling your own. First one didn't work.
They are subpar, let me tell you.
A bit loosey-goosey, huh?
Yeah. They
right. Subpar in what way?
Every way. I don't know anything. Dave, I don't know what I'm doing yet. So literally, like, I should mention, like, so I was.
It's a piece of metal. It's a shaped piece of metal, dude.
I know. It's so dumb. I think the thing was I was kind of like putting too much importance behind what it was. You know, it's basically a monopole. And so Pete Bevilacqua, who we've had on the show before, and Mr. Jeff Mighty Kaiser, yes, sir. They were helping me on Twitter as well. But basically, I'm just trying to get a feel for like a mental model for how all this stuff works. You know, like it's not like you could just change a shape. And I mean, like, yes, as the shape changes, you will have better, properties of antennas. But I can't just pull them out of my keister. You know, I gotta like actually go and figure out what those things look like. So what I was doing is I was using that app note we mentioned 2 weeks ago, that app note 058, which is from TI. And that is a fantastic document. I was reading more of it, and like there's stuff in there about how to do testing and just really, really good stuff. But I found another one. I was looking specifically for 433 megahertz. That's in the ISM band. Like I was looking for an antenna at that level, and there weren't really that many PCB antennas. So I was kind of just like doing my Google image search thing and dancing around trying to find something. I found one dev board, and then I did what every person naturally does, which is, of course, pull in the grainy Google image and then trace over it in Inkscape and make an SVG. It's just a place to start, you know? And at the end of the day, it was a monopole, which is stupid because I could have just, put a hole on there and cut a length of wire. I think it's 100.
Exactly. Yeah.
I think it's
it performed better.
127 millimeters or something like that, and 173 millimeters, so 17 centimeters. And
now, is the performance, is the dodgy performance because of the dodgy tolerance on the milling, or is it because of the dielectric, or is it a combination? What's going on?
No, and this is like some of the good learning that I got out of it is, so it's, as Pete runs antennatheory.com or .net or whatever it is. And if I would have read that, I would have read that a monopole is usually just a dipole where the ground plane is the second half of the dipole. Did you know that? I didn't know that.
Basically.
Slow learner here,
generically.
Dave. Slow learner. And so the problem was that like the shape was good. Obviously, it is fine, right? The shape is really just a way to get a length of wire onto a board in a smaller area, just like you do with a resistor or an inductor. I guess an inductor you want a coil, but if you're doing like a serpentine resistor.
That was the breakthrough in fractal antennas, which made mobile phones and stuff.
Interesting.
Were smaller and more possible. Yeah, fractal because the fractal shape has, so you get the physical length out of it, but in a much smaller area.
Got it. Yeah, like it's folding back on itself.
Yeah,
that's cool. But you need the ground plane there, and Jeff pointed out too. You needed to have it like an equivalent size, effectively. So, and this did not have that at all. So threw it on the VNA, looked at it. It was the wrong size in the first place. Wrong resonant frequency, and then didn't have a big enough ground plane. So basically, what they said is that because now I'm plugging in a SMA cable right into that. And the ground of the SMA is
the shield of the SMA. Yeah, exactly.
So that is hooked into the ground of this thing, and now the shield of that entire cable acts as a thing. So I moved the cable around, and it danced all around, and not a good antenna, but very good learning opportunity. And I've been cutting some other stuff in the meantime, and the RF is a little difficult. Who knew? Who knew, Dave? We've definitely never said that on this show.
They don't call it, black magic for nothing.
Yeah. And then what's really crazy is then Hardy, someone on Twitter, another person on Twitter, Hardy, offered to simulate it for me because, there's like fancy
Yes, there are. Yeah, packages that do.
Packages for that stuff. And then he sent me an image of the actual, like, maybe I'll use that as the image for the show or something, but it was an image of the, like what the radiation pattern looked like, but then also like an estimate of what the resonant frequency would be like, what the S11 would look like and stuff like that too. So, and it was like spot on. I was just like, oh yeah, okay, math. Bring it on.
Got it. Oh, it gets really nasty when you want to properly characterize and model that sort of stuff.
Yeah.
It's, it's really tricky business.
Right. Yeah, and I think about so we talked about, well, I don't know if we talked about it, but I think it's been peripheral to what we talked about in the past about like that iPhone where you had to, your hand was like in the way, right? You had to like hold it a certain way.
Uh-huh.
And that affected the antenna, and it's because, body impacts and yada, yada, yada.
That would be really difficult. If anyone out there is a mobile phone antenna design, because you can't just design the antenna in isolation, right? You can't just go, oh, look, I've designed my antenna from the new iPhone, and it works fantastic when I sit it in a cradle in the middle of the test stand, in the middle of the test chamber. Yeah. But when somebody's holding on to that damn thing, using it like a phone,
right?
It's like,
So Pete, who was on the show, so he talked. You weren't here; it's fine. But Pete actually designed some of the iPhone antennas.
Right.
So he talked about it a little bit, but he couldn't talk about it a lot.
Right, of course.
And he's done some other commercial stuff. But yeah, I think I'm sure we'll have some other antenna people here at some point. But it's been good. The thing that I've been trying to figure out too is like, okay, like just baseline, like what is a Smith chart for?
Right. Yeah.
Still, working my way up to that. But it's, like
they don't teach that anymore, do they?
I maybe think they do. If you're doing, I think you do. If you're doing,
if you did an RF class or
stuff.
did an antenna, yeah.
Yeah. And like, what that's really good for though is like, so say you've got an antenna, you know its characteristics now, you know what frequency it's at. But you need to then match it, right? You hear about 50 ohm systems and stuff like that, and you want to measure the where it is relative, like what is its input impedance, complex input impedance. You want it to be like at the 0 point on a Smith chart, which I have been learning, of course. And
your newfangled Siglent VNA will do that, won't it?
Yeah, exactly. Yeah.
Does it actually have Smith charts built in?
It has a Smith chart built in, which is nice. The thing that I didn't realize about it is that like, so you have a Smith chart, and like there was actually the one time when it was like drawing really slow, which was actually really helpful because what it did is it was drawing, and then I saw like everything was radiating out from the 0 point. It was drawing it like a angle and magnitude kind of thing, so it looked like a polar plot. It is a polar plot, right? And it was actually doing that. I was like, oh, because the curves of a Smith chart always kind of confuse me. Those are actually there to guide you when you want to put in a capacitor or something like that. There's actually Alan Wolke, past guest of the show.
Yes, he's done a tutorial on that.
He's done a really good one and shows you how to do it. And I had someone local here, Danny, was helping me with some Smith chart stuff too. So I'll link in Alan's videos. He's got a couple of them. But I just felt like when I watched Alan's stuff, I didn't have the background to really understand why it was important.
Got it, yeah.
And now I'm getting a little bit more. And this is why, like, so if you ever, so like we've talked about like not block diagrams, but like pattern matching, right? So a lot of times what you'll see on the output, like, so like I'll throw in a Bluetooth chip or something like that. You'll see usually a capacitor going to ground, an inductor going in series, and then a capacitor going to ground. And you'll see that in like the caps will be no popped. The inductor will be there, but sometimes it's just a 0 ohm resistor. And it's like, well, what the hell is that thing doing there?
Why did you bother? Yeah.
Yeah, exactly. And that's there because then you can use those patterns. It's called a pi filter. And you can use that to adjust the matching basically because it's kind of just like a placeholder for later. Yeah.
Welcome to the world of antenna design.
Yeah, it's there's a lot out there, Dave.
You barely scraped the surface.
Oh,
dude.
Yeah. But I think
it's a big rabbit hole.
Yeah, I mean, like the other thing was like I had to like buy connectors. I think I mentioned 2 weeks ago. I like buy connectors and just kind of figure out like N type connectors always kind of scared me for some reason. But they're just
why?
I don't know. It's weird, right? I think just because they were different and foreign, and they're basically just like
irrational fear. There should be a word for.
Well, German word, right?
Irrational fear of connectors.
Yeah. Yeah. It'd be like KonnectorPanik or something like that, you know?
Right. Speaking of iPhones,
Yeah.
this is, it's pretty huge news. We've talked about it before, I'm sure, and it's nothing new, but Apple is investigating pulling up to 30% of its manufacturing out of China.
Yeah. Yeah, and this is among other manufacturers. It's not like it's just Apple.
No, it's it's been an ongoing trend for years now. Of if you don't know, a ton of companies are moving out of China, either completely or partially. They're setting up transition facilities and manufacturing facilities out of China.
Right.
Because, it's like people have suddenly realized, oh, yeah, China's a communist country. Oh, who knew? And China's, look, okay, there'll be a ton of comments now, about
Dave would
what
like to
is the
walk us
real
back.
form of communism, and oh god, yeah, no, seriously.
How about this?
Like
It's
every
a
time
complicated.
I bring it up,
I think that it would be very safe to say it's a complicated regulatory environment in China.
It's a complicated issue. Anyway, yes, and the new trade war is not going to help. The article I linked in on The Verge, it says it's the trade you'd probably know more than Miss being local. Is it starting next month? Like what is it? A 30% tariff on?
It's continuing next month, right? So basically they're supposed to roll in the more of the end device type of tariffs, I believe.
Which is phones and
right,
other
exactly.
consumer
So
products,
previously
right.
it was like end user devices weren't being had a tariff on them, but a lot of the components would be exactly.
Which
stuff
we
you
talked
mentioned
about which is the DigiKey mouse, a tariff thing.
Right, exactly.
The parts, Yep.
And so, as they were very clear of at the top of the article, they say, no, this is not coming to the States. It's just going somewhere else that's low cost.
India, most likely.
Yeah.
But there's many other countries. It's, And,
it's interesting.
So they've instructed Foxconn. And a lot of people think, isn't Foxconn Chinese? No, they're actually a Taiwanese company. So, it's...
right, and they're so big. I mean, all these companies are just so big that they're just going to pick wherever's cheap, and they're going to bring in their processes. And if they need people to, plug in connectors and, wipe off screens and stuff, they're going to do it until the robots are cheaper. Like, that's how it goes.
Right,
I mean, I actually...
India's a fantastic place to go, though, because not only do they have the population of China... right? But half of them have freaking engineering degrees.
That's
right?
true. Yeah,
Every
very
second
well-educated
person
company.
in India has an engineering degree.
I think that might be a generalization.
It's almost a running joke. Seriously, it's almost a.
But I think there's a lot of talent there for sure. Yeah. So it's interesting it's at manufacturing kind of floating around too. They just had a meetup here at my workspace with Korean companies, right? And Korea was like this, and Japan was like this, and China's like this. And
of course.
Manufacturing is everyone's going to eventually move up the value chain, and it's but in the meantime, then wages go up and education goes up, and it's generally it's not a clean process by any means, right? People are. I think there's always a case of abuse, and that needs to be watched for and everything else. But I think on a whole, it's economically, it's a boon for many countries, especially specifically in the manufacturing space, the electronics manufacturing space, because I think that garment manufacturing has not had that same. You look at Bangalore, they don't get the. Not Bangalore, sorry, Bangladesh. My bad. They just that's just taking advantage. I think so. I think, but being around the technology aspect of it all, there's something about that, in my opinion. I have no data to back it up other than my feels.
China. The shift away from China is significantly different though from the previous, the shift away from Japan. Japan was the dominant, high volume cheap manufacturing center, and then it was Taiwan. Right, and then it was China. But the move away from Japan and Taiwan wasn't a political thing. It was because, basically competition, right? The competition came up. So it's not like the India's suddenly come up because of competition. It's companies are moving out of China for political and other, social reasons, right? So it's kind of a different move to the previous ones, which is really interesting, but we won't go.
At the end of the day, yes, so there's politics, but I think at the end of the day, it's money. At the end of the day, politics is driving the money thing, and people are gonna, chase low cost regions just because that's what companies
China isn't
do.
that low cost anymore. We've talked about the onshoring phenomenon over the last
Sure,
couple of
sure.
years, where companies, US companies are bringing and other companies are bringing stuff back on manufacturing back onshore, because it's actually they run the numbers, and it's actually it's not necessarily cheaper to bring it back onshore, but it's like it's on par, or it's not that much more expensive, but they get more control.
Yeah, I think
So it's like,
there's less time delay, less
all that sort of all those benefits, and then maybe that's worth an extra 5% or something.
Yeah,
And
I remember seeing a stat at one point where so United, the U.S. airline, like one of their top clients was Apple, just flying people back and forth to China. Like it was,
really?
Yeah, I forget where I saw it, but it was like some significant amount of their not of their revenue, but it was just it was a large chunk of money. It's just because they have an account set up where people are flying back and forth all the time, and probably a lot of business class too, and so. Interesting.
So this whole Apple thing, the reason it's important is because of the profile of Apple, not necessarily because, Apple's moving out.
Sure.
They might be one of the wealthiest companies on the planet, but, in terms of like hiring people, it's still only, like 1% or something. It's like it's nothing. Right.
You're
but
saying
from
of
a
like
profile
GDP
point of
level
view,
type of things.
Yeah. It's not a huge deal for China, but from a just a publicity standpoint.
Yeah, I guess so.
It's a huge.
I mean, I think
blow.
a better, more less clickbaity kind of title for this would be like Apple is diversifying their manufacturing.
Diversifying,
out of China, right? I'm guessing any localized, like they're still going to make Chinese handsets for China rather in China probably, because that's just going to be the best case scenario. But if you're exporting to the U.S., then why not go to Vietnam or India or something like that?
Absolutely.
If there's high talent, like you said, and lower cost manufacturing. So
I think at the moment they're only talking about their higher end products are going to be made outside or something. So
Apple said they're making some stuff in Texas, but not phones. Yeah.
Right. Okay.
Yeah, and I think it's always interesting thinking about the the auxiliary stuff that's there, like all of the shops that support a massive manufacturing operation like an Apple. It's I think China's better situated for that, honestly. And it would be the most interesting thing to me would be to see are the suppliers to the Foxconn, the factory. The factory's got a huge supply chain internally that's not just parts for the phones, but parts for the factory. Is that stuff still coming from China? And I would be willing to guess that it still is, because I don't think India has the infrastructure yet. I think it'll build up, but I don't think it's there.
No, it doesn't. So. It has some, I'm sure.
Yeah.
It'll come.
Yeah. Yep.
So, but there's other countries. There's Malaysia, for example, like Keysight get most of their gear.
Yeah,
That's where their main manufacturing hub is. They get some stuff made in China, but it's mostly Malaysia.
Mm-hmm.
So they've got large infrastructure manufacturing stuff in place there. So
yeah,
there's
big companies,
lots of options.
Very global.
Anyway,
yeah.
Yep. So that's a big deal. I think just from a a media point of view.
Yeah, you're saying like a visibility kind of thing.
A visibility thing.
Yeah,
it's just like, holy shit, Apple's moving out. So a lot of companies will see that. A lot of CEOs of companies, Apple are doing it.
Follow the herd.
It's like,
MBA playbook.
Exactly.
Yeah, I mean,
they're all talking about it at their big CEO luncheons right
That's
now.
right. Yep.
Yeah.
Speaking of Apple, so there's another a site that I had linked on here. A friend pointed this out to me because he was doing some recruiting, and he pointed me at this Carnegie Mellon Development Center, right? So it's basically like the career center for Carnegie Mellon, which is a top tier engineering university.
Where's that at?
So that's in Pittsburgh, and they're
Pittsburgh.
like really big into robotics. I think they're like top 5 engineering schools in the States, and but what they share is they do data stuff on all of their graduates, and so if you click into electrical and computer engineering here. People following along at home.
I'm clicking.
I clicked on the Masters in Electrical and Computer Engineering.
No,
so basically,
why would you do Masters? Just do a Joe Bloggs Bachelor.
Okay, sure. We'll look at Bachelors. But basically, they track where all of their graduates are going, including average salaries, locations, job titles, employers. And it's really interesting because I was thinking, as I saw this, I was like, I would have loved to see something like this 2 years before I was graduating. Because then you see like who's generally hiring. Of course, it's never going to be the same thing, but at least like, go research them, seek them out at a job fair, and then, find the small ones too. I think the small ones are more interesting personally.
Well, I'll tell you what, the bachelor one is interesting. I'm looking at the pie chart now. Where people have gone after they've finished their bachelors in electrical and computer engineering, which I think are two different fields, but anyway, they seem to lump them together.
Yep.
Okay, and there's a total number of graduates, so there's only 165. Out of 165, only 62 are employed.
That's right.
Whereas 98 decided to continue on.
I don't think that's that unusual. I think that a lot of people
education.
are
you
going
think more people are going on to masters these days?
Especially like a top tier school. So you got to imagine they have 165 grads in their senior class of a ECE program. Like these are these are smarty pants. Like they're smart kids.
Right.
And so a lot of them either were planning to go on or they're going for PhDs, stuff like that. So
got it. Okay.
That's why I had looked at the.
So you think that's a result of the school that's a result of the caliber of the school rather than a general trend in the industry.
Yep. And so I actually ended up going back.
Makes sense.
So the same friend Chris who shared this with me, he said that the phrase to look for, and you can look for this at other schools too. I'm pulling it up. Sorry, is come on Reddit. I didn't write it down. Darn it. I'll find it in a little bit. But there's a search term for it of like so that you maybe like destinations or something like that. And like that's how you can find it. So I actually found it for my school as well. So I went to Case Western.
Oh, okay, right.
And you could find it there too. So
nice. And average salary for those playing along at home with the bachelors is $106,000. That'd be Yankee bucks.
Yeah, which is definitely. I think the average when I was.
Well, the salary range is from 52 to 146.
Right.
Of 40 salaries reported.
Yeah, I think.
So only 40 out of those 62 employed would report their salaries. So.
Right. Yeah, that is lower than I would have guessed out of the. I guess 60. Yeah, 40. Yeah, 2/3. That's not bad.
And what does it go to? Oh, okay. It jumps from. It only goes up by an extra 10 grand. No, 5 grand. Only goes up by an extra 5 grand if you got that master's.
Well, yeah, as an average. So, and I think the big thing... So the thing...
Well, even the salary range, it's from 60 to 155.
Yeah.
So it's basically straight off the bat. As a graduate, it doesn't really matter if you've got a bachelor's or a master's in terms of salary. There's really, hardly any difference in terms of your first job.
That's an interesting... Yeah, that's maybe... I think specific to CMU.
Shows.
Right. I think that's specific to CMU. Because it's like... top tier graduates who are leaving anyways. Now, the other thing that I wanted to point out about this is that this is an ECE program, right? So this is electrical and computer engineering. They have a separate computer science department.
Oh, okay.
Look at all read some of those job titles off.
Which ones? The computer science?
No. So in this ECE report, right? So I was surprised by this is an electrical and computer engineering group, right? This is the school at CMU.
Oh, software. Exactly. Is that what you're getting at?
Exactly right. Yeah. And
it's Amazon. So there's 5 went to their software. Yeah, there's 1 product development engineer. Yay, in South Carolina. Good on you. Yep. 1 applied machine learning research scientist. But software. 1 design engineer. Keeping the faith. 1 firmware engineer.
Right.
Yes. Come on. Is there a PCB design
Yeah, I don't think there
ASIC design engineer.
I think these are good. Well, and so you think about I think about young not influential, the other way around. Easily influenced Chris, right? I didn't give a shit when I was leaving school. I cared about money. Right. I'm going to be honest here. I cared about money. And that's why I ended up going to work for Samsung. And it was interesting too, of course. But I was chasing money. I think about that too.
How much money did you get at Samsung? How much was that? That was your first job, right?
That was my first job. I think I started at
How much money did you get at your
I think it was 55, 53.
Yeah, right. Yep.
This was 2006. So
right.
13 years ago. 53, I think, and then there was a bonus too.
That was good money at the time?
It was not as much as I hoped for, I'll tell you that much. And I know one of my classmates who had a master's, one of my fraternity brothers actually, he had a master's degree, and I think he got 15 grand, 20 grand more than me or something like that.
Right.
So they had performance bonuses and stuff like that too. But that was definitely at different levels. Chris was not a top recruit, Dave. I was among 200 grads too. Like that was like
Right.
the other thing.
Oh,
so
yeah.
I didn't have much.
I love this. Somebody's job title is GPU driver architecture engineer. No, you're a software engineer. It's like, I'm sorry.
That is
driver architecture engineer. You're a software engineer.
Yeah.
Come on. So yeah, that's wow. Okay. What about the bachelor's? That's software. So marketing. Oh, you bastard. Tennessee, bugger off to Tennessee, you marketing wanker.
Easy, Dave. Okay. Easy. Here's the term that it is. It's so student destinations is the search term.
Yeah, student destinations.
So that's how you find if you do like student destinations and your school or a school you're interested in. That's the way to. That's and so. Excuse me. I was looking through others, just trying to find other stuff out there, and there I found a couple. I didn't find much data. I think this is like a newer trend, but I really like it. I mean, this is great. This is great data. Like really great for like. Because just seeing,
but it's not great that everyone's getting into software.
No. I'm saying it's great as an educational tool.
Oh, I know. It's fantastic.
Yeah.
Hey, somebody's an autonomous driving software engineer at NVIDIA.
Yeah, I believe that. There's not a lot of those Jets and Nanos, and they're doing all the visual, camera outside.
Oh, who's working at a company called Okie Dokie?
I saw that one too. Blockchain engineer.
Blockchain engineer at Okie Dokie in Singapore. This is great.
Yeah. Yeah, so there's a couple years worth of stuff. There's other schools.
No, hang on.
Oh,
Winner, chicken dinner. Okay. Literally chicken dinner. Continuing education destinations, right? Some people have gone on to computer science, robotics, technology ventures, mechanical engineering, all that sort of stuff. But somebody's gone, bugger it, diploma in food and wine. I'm going to Lee's School of Food and Wine. Good on ya. Went, none of this engineering rubbish.
Right.
That's I'm getting.
I got my ticket. Yeah.
They'll probably end up earning more.
The smartest one of the bunch, Dave. The smartest one of the bunch.
Yeah, right. Got into food because everyone still has to eat, right?
Yeah.
But when the world's gone to crap and everyone's stopped using their eye farting gadget, then it's great. This is goldmine.
Yeah. It's really great.
Yeah.
So
what did we learn from that?
You had mentioned Okie Dokie, which is a blockchain startup.
Yeah. Oh yes, segue.
So this comes from I had asked on Twitter about what's going on in the electronics world, and Paul Gerhardt has been working on this thing called I'm not sure with how many people, but it's called Kong.cash. Now, I'm about to say some words that I don't like, but this is a cryptocurrency idea. Boo.
Yep.
But it is gorgeous. The way that it was, the hardware that he made is just gorgeous. So Dave, why don't you paint a little picture of what this thing is?
It is a physical polymer type note, but it's actually a flex PCB. So just imagine a very colourful, like the Australian colourful currency, our polymer note currency. So it looks like that. It's all beautifully coloured, and it's Kong is the crypto currency, and it's has 500 Kong note. You have a 50 Kong note, you have a 10 Kong note, and it's a flexible note, and it has an embedded RFID chip on it.
Yeah.
And which generates its own, holds the private key and generates the public key all within the note itself. So you can physically hand it over to another person as cash, as fiat currency, kind of,
Right. Yeah, it's tied to Ethereum, which is I think that's the one that has a lot of developers and block or API stuff, right?
Most of the cryptos out there, except for ones that have their own system, are on the Ethereum blockchain because it has the smart contracts and other technology inside the Ethereum blockchain. So it relies on the Ethereum blockchain to work.
Yeah.
I am
the biggest skeptic. I get it that academically it all works, crypto works, whatever.
Yep.
I'm a skeptic of a practical implementation, but I love this just because
it works. People buy stuff on my store with
no doubt. I'm just saying
you can get a discount. By the way, if you go to the EV blog store, you get a discount for crypto.
Okay.
Sorry,
it's the grandmother test that it doesn't pass the.
Right? No. Of course it doesn't pass the grandmother test. God.
But something like this, I mean, if crypto ever took over and you had to do something where you had physical stuff, something like this is interesting. At least, again, as an academic.
It's fascinating. As I said, off the bat, I said I don't see... It looks fantastic. It's novel, but I don't see a future for this.
Right. And so another thing is...
It's fantastic. I want one. It's just... It looks gorgeous.
There's a tweet we'll link in, too. Like, these things are like... So, like, you know, it's got a fancy animation on the site. But then, like, there's a tweet of an actual piece of Hong Kong cash or whatever. Yeah. And it's just, like, it's UV printed over Flex PCB. Like, oh my God, like multicolor, like it is.
Yeah, it looks fantastic.
Nice design too. Like it looks.
And it's got somebody's like head on, like a Greek head on it or something. Whose head is that? You know? And one of my first thoughts was that can it be used as a wallet? Can you like charge it up with currency and do that? Because if you could do that, technically that would be possible. But then that'd be pointless of printing a note which says 500 Kong. Yeah. It's just you may as well have it on a. You know, it just defeats the entire purpose. And then my next thought was that you could physically, like, because everything's stored within the chip, right? So you could physically hot air the chip off, move it from a 500 Kong note to a 5 Kong note, or vice versa, and, you know, bingo, you've got a counterfeit.
And people thought that learning how to use a hot air pencil wasn't going to pay off in the end. You know what? We're going to show them, Dave. We're going to show them.
I'm going to counterfeit my 500 Kong notes now with replace them with 5 Kong notes. I'll make a killing.
So this is an interesting chip too. So the ATEC 608, it's ATECC. So it's in a secure storage thing. I had actually I'd written an article about this. I didn't know much about it, but I wrote an article about it for the Things Network a while back. The idea is it's like a secure storage element, like, who makes it? Microchip? But it's like, I don't think there's any security vulnerabilities with it found yet. I think I talked to Colin O'Flynn, past show guest, about it, because I was wondering like side channel type of things on it. I don't think anyone's gotten that stuff out of it yet.
Right. Interesting.
So. Yeah.
And is it a physically secure chip as well? Does it have like the little micro mesh in it and all that sort of stuff to stop and attack with acid and all that sort of jazz?
I don't know. I should probably look at that.
You don't know? Anyway, it's cool.
So I see these things popping up all over the place. So like anything that's like, so I saw a reference design that was talking to like AWS, and it has one of these on there, and it's used in like Google Homes and similar things like that. Basically, it's like a key manager for, getting stuff online.
Yes, one of those USB key manager sticks. So you carry around your USB stick, you stick it in, and it gives you your password access to everything.
Yeah,
is that what you're talking about?
It holds it holds the secret key, and then I think you do a challenge. Boy, I'm out of my element here. You thought crypto was going to be bad, or RF. Wait a second, Chris is going to talk about cryptographic generation of keys. Yeah. So, anyways, we'll link the datasheet in. How about that?
Anyway, Kong.cash.
It is.
I didn't know there was a .cash extension.
Oh yeah, you had to imagine.
I'm going to have to buy. EEVblog.cash just because it's cash, and I'm cash fanboy. I'm a cash aficionado. I did a wallet review.
Yeah,
I've branched out into wallet reviews.
Oh, I saw that. I didn't watch it. Sorry, it didn't grab my attention, Dave.
I'm sure it wouldn't have. That's all right. I just did it because I could. You know, it's one of those things. And anyway.
Well, we'll link that into the wallet review. It was like a really thin one or something.
Yeah, it was one of those the world's thinnest wallet.
I love that teardown you did. The millivoltmeter thing.
The millivolt. I got taken to task. I got taken to task by the fanboys.
Okay. Well, first off, let me promote the video first.
Okay.
If you want to watch Dave freaking out about hinging units for like half an hour, it's very fun. It was a really cool construction. But you're saying you got taken to task for what?
I got taken to task because all the fanboys out there said, "How dare you just call that a millivoltmeter?"
I see.
It's a selectable bandpass. I called it a fancy pantsy millivoltmeter, and that's what it is. No.
Yeah.
So
you said
I'm going to continue to call
DC,
it that.
I believe, right? So it implies you need some kind of filtering system in there, right?
It's a fancy pan. You can use it as an actual receiver. Apparently, you can hook up an antenna to it, and you can selectively dial in the bandwidth you want, and and it'll decode it, and you can actually tune in stations and stuff.
Okay.
It's actually, it's a fancy pantsy millivoltmeter. Sue me. So I'm going to continue to call that just to troll everyone.
Got it.
So,
yeah.
Yeah.
Yeah, so people haven't seen it. Basically, it was like a modular approach. Could you tell from like taking it apart that were those standardized block sizes? Because there's all these cans.
No, everything was custom.
So that doesn't make sense to me though. Like, so from a reusability perspective, why would a designer do that?
They don't care about reusability.
Okay, so it's not modular in the case of wanting to reuse it. It's more
not
modular
between products. No, they wouldn't be using.
So it's more of like
cans between
like
products.
looking at a VNA or something where you see each block, not a VNA, well, any like RF design where you have like a certain element and then surrounded by nicely grounded gold areas.
Yes.
It's just that.
The schematic modules you could reuse, of course, the actual circuit modules. And that's why they did it, is because modular design is easier. You can break everything down. You can individually test each module. You can have different design teams or people working on each individual modules. And you guarantee when it all comes together, it's going to work because each module has been individually designed and validated and tested. You can't just whack them together. You can completely come a gutser because all the different penetrators between the modules and just the ground interactions between all the modules are going to ruin your day.
Yep.
Right. So it's and apparently someone pointed out that I missed a whole level of cans in there I didn't take apart. So I'm going to have to, after this, I'm going to have to go back in and go,
Too much stuff. Yeah.
There were like 4 levels of, apparently I only did 3. So I'm going to have to double check. But it's gorgeous. Yeah, 1980s German technology. It's just, wow. Everything is a modular block. Like,
yeah. And I like that idea too. Like the idea of like black boxing. I mean, like again, going back to like school days too. Like they talk about like like transfer functions basically. Like you're treating each block as a transfer function effectively, and it doesn't work like that in practice, like you said.
Right.
But it's an interesting mental model that then they took to an extreme with like shielding and cans and everything else.
Well, it makes development of advanced products like this, because this is like back in the day, it's like 40 grand. I think somebody said $45,000 bit of kit in today's money.
Wow.
Right? Just for basically a fancy. How much in Kong? For a fancy, that's a lot for a fancy millivoltmeter.
Yeah.
Right?
Yep.
And it's a level meter, technically, is its name.
Level meter.
Anyway, right. It's a selective bandwidth.
It's a milli-level meter, right?
It's a milli, yeah.
The level is a millivolt.
And where was my train of thought going on that? Oh, God, you lost me.
I think you're talking about like piecing things together, people working independently.
Oh, yeah, piecing. It's when you're designing such an advanced product, it makes sense to make everything modular, just like they do inside spectrum analyzers even today. They just break down the modules, and that's why you physically see them separated inside there. You don't necessarily have to do that from an electrical layout point of view. Sometimes, you stop cross-coupling between modules and things like that. But, it's, it just makes the design easier. Right, that one's done and dusted. We've tested that. Because a lot of these spectrum analyzers and stuff, they are modular block designs, effectively. Like one, it goes into a bandwidth filter. Right, a bandpass filter, and then it goes into a mixer, and then it goes into a down converter, and then it goes into a detector or whatever. They're all separate functions. And so it makes sense to separate the designs out.
Yeah. Both
physically and in terms of your schematic as well.
Yeah, I think about it like most of the time, the designs I've been doing lately at least, it's like some kind of processing element at the middle. And, there's not just a lot of like signal path type stuff happening. It's just basically like usually it's signal path is like input,
signal
protection.
Path is the word, that way.
Yeah. So like input, protection, maybe amplification into an ADC, and you're done. And then it's bits.
Right.
But like what you're talking about.
And you sort of treat that as, it's so simple, you treat it as an entire design.
It's one input, and then there maybe are other ones, but they're all going to a centralized place, which is the micro or the FPGA or whatever, right? This is like, it's a serpentine, like, block, maybe a relay to split it to 2 different places, block.
Did I put the block diagram in there? I'm not sure
I don't
if
remember.
I did.
Yeah.
But oh my god, yeah, it's wow. There's like dozens and dozens and dozens of blocks all interconnecting. It's a serious bit of kit.
Yeah, you should put if you're making another video about it, you should do that in the block diagram.
Yeah, I'll
would be cool.
definitely. I was going to actually go through because I got the service manual. I was going to go through it, but the video was already long enough.
Yeah.
So which has all the block diagrams and stuff.
Cool.
So I'll do a second video and include that.
Yeah, and so speaking of signal path, if you watch like Shahriyar's videos, he does that all the time too, where he breaks it down. Into
he
like
goes through the
blocks, and then he says, this is the section
Yep.
that's doing a filter or a amplification or whatever, and it matches that pretty well, I think.
Yep.
So
because that's how all these RFE things work, which is what he's into.
Right.
You know, it's like
Yeah, what makes them interesting too. Like it's not just if it's you look at like an SDR, you're like, oh look, it goes into the ADC, and then there's a DAC that goes out the other side.
Yeah.
Okay.
But if you look at how to lay out a schematic, the video I've done, like how to do a proper schematic and stuff like that, one of my things is to like draw modular, like draw a box, group your schematic together in functional blocks and draw a box around that block and give it a label. This block does this. And
the KiCad fans out there will know about hierarchical schematics, which allow you to do that exact thing.
Yeah, of course.
Yeah. So.
Yeah. That's the way to go. That's the ticket, laddie.
Yep, that's good. Well, that's cool.
Yeah.
Are you actually? Did you get it working? I saw you said the button doesn't work.
No, it doesn't. No,
so it's just a teardown.
No, it's completely dead. It's a lot of effort to get it apart. A lot of people are asking to.
So
what and stuff.
So if I had 45,000 Kong in $1980, what would I be buying it for?
You'd be buying it for telecommunications.
Got it.
Testing the lines and the systems in telecommunications stuff. So you can dial in a particular bandwidth within like a particular part of the because old school analog telecommunication channels, they're broken up into different bands.
Right.
So you can like tune that one band and then listen to that one band and check the signal level in that one band, or I'm sure there's more to it than that.
No, and it's probably at a millivolt or so.
Yeah.
So that's good. It makes sense that you would have a millivolt meter.
Yep.
That's great.
And so somebody brought this up on the EUV blog forum. They said, "Oh, I need a new multimeter." It was in the beginners section. Can anyone recommend a multimeter that does that? I'm looking at measuring like hundreds of microvolts AC signals, and then I went in. Multimeters don't do that. That's what AC millivolt meters are for.
Oh, okay. Yeah.
And so I put links to AC millivolt meters, and like I found even, I didn't know this, Uni-T, maker of the finest cheap-ass multimeters, they did a dual display AC millivolt meter. I don't think you can buy it anymore. But, AC millivolt meters, people, if you actually remember them at all, or if you've ever used one, most people will never ever used an AC millivolt meter in their life. But they're usually old school analog ones, and you can still buy analog AC millivolt meters, brand new.
So it would just be like a power level on that, or what would it be?
It's basically a signal level. It doesn't do all the fancy stuff that this Wandel and Galterman $45,000 one does.
Sure.
It basically, it just measures low-level AC signals over the range from microvolts.
Right.
Or
you want to see if your signal's getting through, and if
millivolts.
it's at this maybe at a certain band, a certain frequency or whatever. Yeah, that's interesting.
Yeah. Because the problem with your general multimeters is that the true RMS converters in there, they aren't good at low-level signals. If you actually go read the fine print, the little asterisks inside, a lot of people don't know this, little asterisks inside your user manual specs for your multimeter, it'll say, the accuracy, your AC range, your AC millivolt range might be accurate to 0.5% or something. That's because like you can't get 0.005%.
Right. Yeah, because your cap's not huge, and you don't have like a really high quality caps in there and stuff like that.
No, and anyway, so it's 0.5%, but little asterisk says only above 0.1% of full scale or something, right? So if you're measuring if you get under a threshold limit, the converter goes all wobbly and doesn't know what it's doing. It can't do it because it's got rectifiers in there. It's got to rectify it and everything else. So it gets a bit non-linear down in that low-level region. Right. So, some meters are different. And of course, so the only other way to do that is to use an AC millivolt meter, which doesn't measure AC the same way as a multimeter, a digital multimeter does with its true RMS converter, or you need a scope with a preamplifier front end.
Right. Yep.
They're, that's the only way to do it. So AC millivoltmeter, the long forgotten.
Yeah. You mentioned who was the you said they Wave Tech, not Wave Tech. It was Wave someone. Wave
Tech. Yeah.
Was that who they bought?
They Wandel and Galterman bought Wave Tech. Technically, it was a merger, but yeah, right.
Is it?
We have a segue for that. Yes, Onshape, which is the online 3D CAD tool.
Oh, I didn't realize what. I was wondering. I was wondering why you posted this before the show, but I know why, because you guys use it.
we use Onshape. We use it for the micro supply case, and they have a free version. Right. If you don't know, it's free and it's an online tool. It works in the browser.
Yep.
David used it, he loved it at first, and then he started using it in depth to design the micro supply case, and then he started swearing and
that's how a lot of tools are. I mean, they start great, and then you get deep into them, and the veneer comes off.
Yeah. But anyway, no, he finally figured it out and made it work, and it's Anyway, they've just been bought out by a company I've never heard of, PTC.
So PTC is Creo. They make Creo, which used to be Pro E. So Pro Engineer.
Pro
yeah,
E.
they changed the names a bunch.
Pro Engineer. Okay.
So PTC, I think, is a bigger company, anymore. But they made Pro E, and that's how. Yeah, that's
right. So Pro Engineer is now Creo.
That's right. Yep.
Oh God. Okay. Right. Okay. Fair enough.
Yes. I just always know because I always say PTC Creo. That's like when I hear designers talking about or mechanical folks talking about it. So it makes sense.
I had no idea.
Yeah. There's.
Right. Yeah, because that's a standalone product. They wanted a cloudy solution.
That's right. Yeah.
Product,
well, they might have something there, but I'm not sure.
Yeah.
It's not cheap.
Anyway,
that's for sure.
Right. Got it.
Yeah. Creo's nice. They're all fancy.
Oh yeah, no. When you pay top dollar for that, they're all nice. Yeah, of course.
But we'll see if the free stuff sticks around. I keep hoping. I keep meaning to. I don't have anything that I need to make right now. Last time I did a 3D design, I was just doing it in Fusion, which is good. But on my list is to.
So do they have a free version, right? Fusion.
Fusion has a student and hobbyist and startup version, and so it's if you're not making more than $100,000 in a year, then you're a startup.
Right.
Or something. I don't know what the numbers are, but it's startup and it's So they have a free version, but free is always it's until they decide not to be free, which is going to be potentially the same thing for Onshape, right? So,
of course.
I won't call it a New Year's resolution or anything, but next major design I do, I want to try out FreeCAD some more too, which is a open source. Open source just hasn't. It's tough. This visual stuff is just not. FreeCAD is better than it has been. It's definitely improving, but it's 3D stuff.
But
it's just
not
tough.
quite there yet. Is what everyone tells me.
Yeah. And I tried out the scripting one too. What is that called?
Oh yes, Open SCAD.
Yes, I tried that. Started by former guest Clifford Wolf.
Oh really?
Yeah.
Oh,
isn't that great?
There you go.
Yeah. He doesn't maintain anymore, but he started it. So
right. Okay. Cool.
And it's I'm not a software person, as we may have talked about in the past. And software people love it though. I don't know why. But
right? Yeah, I know. Yeah, they get all moist about.
Yeah, it's a lot of nested functions and stuff like that. So
all that sort of jazz. Oh,
it's an interesting idea for sure. I mean, the idea of parameterized models and stuff like that, kind of cool, but not quite there yet. So,
right.
Yeah. So do you think this will impact you though, the buyout, or no?
I don't think so.
Okay.
We'll see. There's no point at the moment to panic and extract our design out and move to something else. But,
I mean, and if you have
I'm sure there'll be forewarning. This is a huge company. They aren't going to suddenly, go bust and the tool's just going to stop working.
Yeah, I think
they suddenly change direction.
I think if they change direction too, you're like, all right, I guess I'm going to pay. This is the business thing. I think it's
no, of course.
a bigger deal for open source projects and stuff like that if they're dependent on the kindness of a
But in
loss leader.
5-10 years' time, do you expect your online browser on-shape design to still be working?
Right. Yeah, it's a good question. I think
maybe 5 years, but 10 years down the track,
Right.
It's like,
right.
Yeah, it's one of those things. But that's that you know that going in. If something is web-based and you don't have the executable file that you can back up and store on your own hard drive forevermore and keep it running forever, then that's the choice that you make.
Yep, definitely.
So there's nothing you can do about it. So can we talk about dumbass design?
Sure.
Please.
Who are we talking about here?
Tesla.
Oh,
Tesla.
What about him?
Yeah, their flash memory
Oh, yeah, that thing.
is all dying, and the black screen of death in 4-year-old Teslas, apparently. Apparently a lot of Teslas are, because they use flash memory, of course, and flash memory has a limited number of writes, and of course Tesla love to log stuff, so they're logging everything, furiously right into this flash memory, and 4 years later, all these cars are dying because all the flash, they've exceeded the number of flash writes. It's like, this is like basic design 101, schoolboy level mistake. Like,
I would make this mistake, but I would assume that a
but
big company wouldn't. Yeah,
it's exactly. I can't believe that somebody at Tesla didn't go, hey, there's a limited number of writes in this flash, and we're writing into it 1,000 times a day. Like,
right. If there's any Tesla engineers or former Tesla engineers out there listening,
former, it'd have to be former.
What would be a good email address here? Secret stuff about Tesla at theamphour.com.
Right.
I'm sure there's a reason for it. Like, I doubt it was an oversight. I'm sure it was more of a design risk, and then it was just if it wasn't tested for, right?
Yeah, but no, it wouldn't be a design. Like, if you showed the numbers to if an engineer spoke up in a meeting and said, hey, look, I've ran the numbers, we're only going to get 4 years use out of this, and then it's going to die. Like, no one's going to go, oh, don't worry about that. It's either they were too scared to speak up. I can't believe there's nobody there who didn't calculate the number of writes. I mean, it's just, it's so fundamental. Everyone knows about this, especially at that sort of design level.
I don't know, Dave. It's easy to look at. I think it's easy to look at a design decision after the fact and say like, oh, how could they have done that? But then I made mistakes. I'm sure you made mistakes. I think the bigger thing is just that it's a team. With a team, it's harder to believe, but it slips through the cracks. I would be very interested to know if this was not that it was a surprise, because surely it was a surprise, or else they would have fixed it. But just what the thinking was there. Because if there was we expected, maybe the logs went up, you know what I mean? Like, if a software engineer decided to log more stuff than they thought,
log more frequency, and nobody right. So it passed the initial design thing, and they went, oh yeah, we've calculated it's going to last 20 years, and that's longer than the life of the car. And then the software people 12 months down the track actually implemented these software updates, and then without going back to they write more frequently.
The other surprising thing about this was
consulting the hardware engineers.
I don't see it in this one. I think I saw it in a different article, but they said the replacement cost was like $1,500 for the board or something like that. It was like, oh my god.
Yeah, well, because you cannot get Tesla parts.
Well, I don't need Tesla parts personally. I can't afford a Tesla.
Yeah, but no, you can't. No, but even repair places can't get them. Apparently, they have to scrap old Teslas that have been in accidents or whatever. They just vulture out all the parts because that's the only way to keep your Teslas going. There's a whole black market for all these aftermarket Tesla parts, and these companies that have sprung up that specifically hack Teslas, and because often you have to hack them to put in these car parts from a different car or whatever. You've got to hack the serial number. If you've got to hack something else, I don't know the thing behind it, but it's not good. Wasn't the car covered under warranty? Usual cars are like 5 years plus warranty these days. Wouldn't you just?
Dave, I'm going to sound like a yuppie here, but I do not have a car anymore, and my only car I've ever bought was from 2004.
Right, okay.
So, that's long gone. Are they covered by warranty that long? I guess. I don't know.
All right.
I'm always surprised.
And, well, apparently not, because they're going to these unauthorized repair places because that's the only way to get their Tesla back on the road.
Yeah, and if you had that big investment, you'd be like, no, I'm keeping this. This will work.
Exactly.
I will get this working right now. I think I remember we talked about this a long time ago, but it was like I was always surprised that they didn't have removable screens. Do you remember we talked about like tablets? I always thought that would be a good idea of like tablets or like removable consoles and stuff like that.
So you're talking about the Tesla screen to rip it out and it becomes a tablet?
Yeah, I mean, well, not to become a tablet. I don't need like a piece of commercial stuff. I just mean like that stuff. It feels like everything is so because of sourcing issues, right? And I'm not sure I stated this nuance back in 2011 when we started the show or whenever this was, but like because of sourcing issues, thinking about like a screen is so far, like. Display technologies are so leading edge, and sourcing for automotive with all the testing requirements, everything else is not so trailing edge, but definitely not leading edge. That they wouldn't have been replaceable in the first place. Like that always blows my mind, and I'm sure there's reasons for it, but like this kind of points to like a replaceable unit, at some point. Like the fact that it's not.
This is where the car companies, you can't just go, oh, my LCD's failed. Oh, let's just get another off-the-shelf one from a manufacturer or something. It's like they have to manufacture these at the time of the car, and they keep them in storage. They keep, this is how all your Toyotas and your Fords work. They manufacture. A million cars, and then they manufacture a million spare parts, and they keep them in massive warehouses of all these. Spare parts, and that's how it's going to work here, I'm sure.
Yeah.
So I'm sure there's a warehouse full of Tesla LCD screens somewhere.
Yeah.
That's if they are a proper company and they automotive company and they thought that far ahead.
So I guess the better question is then I don't know how to do this stuff. Like, what would have been the better way to do this? So say you had these mass amount of logs. How would you put a different hard drive in there or something? Like, I guess, is it overwriting itself?
You use a different technology. You would use an FRAM, or you'd use some other technology, and then or you buffer it. The other way, the traditional way to do it is you buffer it during the day. Okay, if you need to write logs 1,000 times during a day, you don't write a log each time. You write it to even some battery-backed SRAM somewhere. You physically write it to, and then you do once a day. You run a little thing which then dumps at once. So you're writing just once per day instead of 1,000 times a day. That's the traditional workaround for this. So
it seems weird to me, right? So I imagine that so just thinking about Linux systems that I play on, which is not great, right? They said this is just
sorry, if people don't know, this is an
eMMC,
eMMC memory, so they're using it like a hard drive, So the software engineers didn't care. They just go, I'm going to just save it to the drive, right? And the thing's wearing out.
Yeah.
So it's more high level. It's not like a low level embedded, PIC chip with its 32K of flash memory inside it. It's a high level operating system.
Right, it's got
drive.
512 gigs of flash or something on there, right?
Something. And it's appearing as a C drive or whatever for some Linux operating system it's running. I don't know what's running.
Yeah, some of the tweet comments are about Linux, and my limited knowledge of Linux is just that there's /var/log, right? That's where you put a bunch of stuff, and if it so the server that the amp hour runs on, when it gets hit by basically someone asked for a request on there, it logs all of that stuff, right? And it's only there's it'll log everything in there. It's just garbage. Not garbage, but it's it's just lots and lots of stuff for tracking over time. I imagine that this must be overwriting itself though, right? So in that same total amount of memory space, even if you must be clearing it out, it must be generating so much info.
Oh, it depends.
That it's clearing it out and then writing it again.
So keep the last week or something.
Right.
I don't know.
So I'm just thinking about what would be a better way to do this? Is do you have a removable what are those called?
Well, you store it offline in the cloud. The Tesla already does talk back to base, right?
Yeah, you wouldn't put logs there.
GSM built in.
You would spend tons of money on data then. You know what I mean? This is
Yeah, but no, data in the cloud's cheap.
No, not in the cloud. I'm saying getting it to the cloud. It'd be going over cellular connection. I can tell you that's friggin' expensive.
No, that's built into the Tesla. The Tesla
No,
does
I know,
that
but they're not
already.
sending
The Tesla
logging.
is always reporting back.
They're not sending Linux logging data. I guarantee that they are not doing that. They're sending. Yeah, I'm sure.
No, but they could. I'm saying it's already reporting everything back.
No. Okay, let's do a little
why
thought
not,
here.
Why
So
not report?
let's say you had a 512 gig just thing on there, right? And it's getting overwritten so many times, it's generating so much data that it's passing.
No, it's not that much.
Okay,
It's
I'm
not.
just
It's
trying
not
to.
hundreds of gigs per day.
No. I'm not saying
It's
per
not
day.
that much.
So
Yeah.
okay, how many days? So it's 1,200 days in a 4-year span, right? So
Right.
let's assume that it's like I think memories are guaranteed to like 5 or 10,000 writes, right? So that means that you're probably generating like 2 or 3 gigs per day of logging data, which is insane, but it must be something like that, right? If you were
That's nothing for a modular cellular connection.
no, it's nothing to do it. I'm saying the cost of doing that is insane, Dave. That would be 2 to 3 gigs
that's
a day.
part of owning a Tesla.
2
it's
to 3
built
gigs
in.
per day? Oh my god, that would be terrible.
No,
Yeah.
no, it's not. I'm on a $50 plan and I get like 60 gigs. Oh, sorry, a month or something.
Yeah.
No, I get 90 gigs a month or something. Yeah, but I don't think it's as bad as you think it is.
I think that'd be pretty bad. I think that'd be a lot of data.
No, I don't think so. Anyway, you're talking about solutions, right? That is one solution.
That is one solution. I agree with that.
Is to
yes.
dump it back and dump it to the cloud.
I think that would be a
Right?
big waste of bandwidth. But yes, that is a
Sure,
a
okay,
solution.
but it's better than your car dying, right?
Yeah, that's true.
Like, come on.
Yeah.
You're asking for possible solutions. That's one
Yeah,
of them.
I was
That's
thinking
one
about
of the
like
ones you'd investigate.
removable storage too. Like maybe not an SD card but maybe like a SATA drive online. You know, you could have it so that that thing pops off, right? You could have like an eSATA.
Well, no. Look, if I was on the Tesla design team for this, and I knew there was a limited number of writes, right, and it's got this computer, what's it called, the
ECU?
ECU1 or something, right? The ECU1 module. If I was in charge of designing the ECU1 module, I would like have a little, as you said, like a removable, even if you have to like open the bonnet or get under there or whatever, at least, get in there and have a
ECU1.
physically removable drive that the job of that drive was only to store logged data, right? So if that drive died, like it doesn't matter, okay, your logged data's gone. Right? Who cares, right? The car still works, all the I was going to say avionics, all the,
It's drivionics, Dave. Drivionics.
Or the drivionics still works, right?
Yeah.
All that sort of stuff still works. But no, this is like so integral with it that it's they're just storing it in the same drive that they're using for all the display stuff. So the displays are dying and going black, and you can't drive your car. Or you can, and you can't charge it anymore.
What
It's
I was
like
gonna get
it's
at-
bad modular design.
I thought of the same
Bad.
thing about like we were just talking about removable, but then they must have like shock and vibration type concerns as well, right? So
Of course.
Yeah. yeah, I don't
But
know.
but still, I would no. Come on, that's easily solvable. As someone who comes from that background, I can tell you that's the least of your worries. Right? No, they just stored everything on the one drive. It was a dumbass decision. Somebody should
People
have
can
stepped
write
in and
into
said, "Hey,
no,
know.
Dave, you're wrong at theampower.com. That'll get directly
Please.
routed to Dave.
and automatically trash me."
That's right.
And no, it's just no.
I think it's really
poor-
tough to look at this from the outside and say that we would have.
No, it's easy to look from the outside.
Well, it's easy for you. I would not have said this, but Dave, you are a bold individual to say you would have gotten it right.
Well, no, come on. When you're working on a big design team on a big product like this, one of your jobs is to think of ways it can
Sure.
it can fail and how one thing doesn't. This would be a huge thing in automotive design. How one thing doesn't take out something else, especially in a car which is so computer oriented like this one. Come on, it'd be like a design requirement almost number one that if one part, if your login system dies, it doesn't stop the car from driving. I mean, for goodness sake, surely that would have been top of the design tree for this sort of thing. I mean,
Dave, I just
seriously.
I live in a
When you've got
glass house of design, and I shan't cast stones. So
I'm just flabbergasted that I can understand how it happened, but it shouldn't have happened.
Sure.
Right?
Yes.
Sure, like having all your eggs in the one basket like that is just, So if one part of that dies, it's like, geez. If your login system dies, your car stops driving. I mean, give me a break.
Yeah, it is all interconnected, so that's rough.
Anyway. Our hour is well and truly up, and we haven't even talked about the chip printer.
We haven't talked. You know what? We should leave the chip printer. Let's just let that one lie.
All I'm going to say is I was right 10 years ago, and I'm right again now.
I will say this thing looks ridiculous.
Even though it's on Kickstarter.
This thing looks ridiculous. Oh man, it's raised $130,000. Y'all just lost your money. Yes. Oh yeah. This is it. Said we have 8 different heads to do this stuff and do electronic stuff.
Oh, so you're not pro this?
Oh no, God no.
Right.
This is not it. This is, if there was going to be a chip printer, it's not going to look like this. And first off, they said things like there's N-type semiconductor and P-type semiconductor filament. What the hell does that mean? Like that boron doped flexi material, that's ridiculous. This is.
Well, technically, you can make a piss poor transistor
to troll you,
out of
Dave,
it.
But it doesn't. It's not going to work.
I know.
It's not. Yeah.
I know. It's just I'm sorry. I was right a decade ago. I'm still right, and I'll still be right in a decade.
Well, yeah. Well, we'll see in another decade. 10 years is a long time.
Oh, come on, dude. You're not clinging on.
Yeah. Interestingly, though, the cost of so we always said FPGAs, flexible stuff like this is actually something that was submitted on Twitter by Frank just before we started here. I had not seen this previously, but all these cheap boards I keep bringing up on the show, like the Cypede and all those. Yeah. So they have an FPGA on here that I have not seen before. So this is a new FPGA, maybe not new, but new to me for sure. It is the I don't even know the site that this is on. Alcom Electronics. FPGA. It's got 1152 LUTs, 864 flip-flops, 72K of block SRAM. And so the crazy thing though is that the board with an FPGA on it at Seed Studio, again, these are all pre-ordered, Seed just keeps cranking out these pre-ordered boards. So, that's the GD32 that we talked about in the past weeks and stuff like that too.
Yep.
$5 for an FPGA board. So that's kind of interesting. I don't know much about it yet, but $5 for an FPGA. That and the fact that we've always talked about there being 4 FPGA vendors. There, maybe a 5th.
Yep.
Well, we're not quite there yet, but just someone else new in the market is kind of interesting.
And there's Chinese ones, isn't there? And all these ones we haven't heard of in China.
I have not heard of any. I don't know of any, but I think this is what this is. So.
Okay.
Oh, this is sorry. It's GoWin. I don't know what the hell this is. GoWin or Alcom Electronics. Well, I'll link them in, but
cool.
GoWin. GOWIN. So.
All right.
This and more conjecture in future episodes of the Amp Hour. Thank you for listening.
That's it. Catch you next time.